Waking up 400 meters above the valley floor triggers a primal response. Between the sleeper and the abyss lies only a single sheet of glass. This is where engineering declares war on vertigo. These structures are not merely built, they are anchored against the impossible. Every pane of transparent material acts as a critical shield against wind shear and the relentless pull of gravity. The fear is biological, the safety is mathematical. But precisely how thin is the line between structural integrity and freefall? We clip into the first anchor. 400 meters above the Urubamba Valley, the only barrier between a sleeper and the void is a shell of aerospace aluminum and weather-resistant polycarbonate. The capsule dimensions are precise, 2,400 by 2,600 millimeters of habitable cross-section. This is not masonry, it is high-altitude rigging. The structural integrity relies on a series of industrial anchor points drilled deep into the solid rock face. Steel cables pull taut against the stone. The tension is absolute. When the Andean winds accelerate, the suspension lines hum. A low-frequency vibration travels through the mounting brackets and into the aluminum floor frame. Against the sheer scale of the mountain, the suite appears as a fragile bubble of air clinging to a geological monolith. Inside, the environment is strictly controlled. Solar panels charge independent battery banks to power the lighting and ecological sanitation systems. The logistical complexity of maintaining a habitable vessel on a vertical cliff defines the market value. A single night of suspended engineering costs roughly 450 euros. While the Peruvian capsule asserts itself as a foreign object of aluminum against stone, the next engineering challenge attempts the exact opposite: radical camouflage. Deep in the Patagonian Biological Reserve, the Montaña Mágica Lodge abandons aerospace alloys for a masterclass in hydrodynamics. The structure is a conical monolith built from volcanic rock and wood designed to mimic a dormant volcano, but the active mechanism here is water. A hydraulic system pumps fluid to the apex, releasing a continuous cascade down the rough exterior. This is not aesthetic, it is functional biointegration. The constant flow cultivates a living skin of moss and ferns, physically merging the architecture with the rainforest. The falling water creates a liquid curtain that serves a secondary invisible function: acoustic isolation. The turbulence of the cascade generates a wall of white noise. This sound barrier absorbs specific frequencies, effectively masking the sharp calls of the jungle fauna. To enter, guests cross a suspension bridge that vibrates with the force of the flow. Outside, the water roars. Inside the 9 timber-lined chambers, the decibels drop to near zero. The chaotic frequencies of the wild are filtered into absolute silence. While the previous design mimicked organic currents, this project attempts something more radical: total optical disappearance. In the frozen forests of Harads, a 4x4x4 meter cube hangs suspended around a single pine trunk. The facade is clad in highly reflective glass. It captures the surrounding canopy in the sky, bouncing the image back to create a perfect camouflage. From the ground, the structure does not exist. It is a glitch in the landscape. But invisibility creates a lethal hazard for local fauna. Birds fly directly into the reflection. The engineering solution relies on the light spectrum. A laminated infrared film is sandwiched within the glass panes. To the human eye, the surface remains a flawless mirror. To a bird, the ultraviolet layer screams obstacle. The connection to the host is equally precise. An aluminum frame creates a rigid cage around the tree, using friction rather than bolts to preserve the flow of sap. Inside, the contrast is sharp. The wind hits the glass with a hollow thud, and the floorboards vibrate as the pine sways. The single trunk supports a suspended mass of 4 metric tons. From invisible barriers in Scandinavia, we shift to direct physical contact in East Africa. Nairobi, 1932. A colonial manor dominates 12 hectares of bushland. Originally designed as a Scottish hunting lodge, the stone structure has undergone a functional inversion. The target is no longer a trophy, it is a guest. The Rothschild's giraffe stands 5 meters tall. That is the height of a standard street lamp. To bridge the gap between human and megafauna, the architecture exploits verticality. The building's high-ceiling geometry aligns perfectly with the animal's feeding mechanics. Reinforced sash windows on the upper floors act as access ports. The frames must withstand the leverage of a neck weighing hundreds of kilograms leaning in for food. Conservation drives the engineering. The manor serves as a breeding ground for a species on the brink of extinction. The luxury revenue funds the survival of the herd, but the interaction is raw. The sash slides up. A massive ossicone-topped head breaches the interior space.
While Kenya invites nature inside, China forces concrete into the shape of gods. In Hebei province, architecture abandons utility for total mythological dominance. Standing 41.6 meters tall, the height of a standard 12-story apartment block, the Tianzi Hotel is the largest image building on Earth. It is a structural colossus representing the deities Fu, Lu, and Shou. Engineering here bows entirely to aesthetics. To maintain the illusion of a solid sculpture, architects camouflage the windows within the intricate patterns of the gods' robes. A massive ceramic hand blocks the sunlight. A fold in a polychrome tunic becomes a viewport. The scale is oppressive. The shadow of the central deity alone covers half the parking lot. This gigantism creates a logistical nightmare inside. Walls curve unexpectedly to follow the geometry of a beard or a sleeve. Standard hallways turn into angular labyrinths. The ultimate expression of this conflict is the suite located entirely inside the Peach of Immortality held by the god Shou. A guest sleeps inside a spherical fruit made of reinforced ferro concrete. This audacious prioritizing of form over function earned the structure a Guinness World Record. But while concrete must be poured to mimic life, the next material on our list is actually alive. If the Tianzi Hotel mimics nature with concrete, then on Bali, the material itself dictates the form. Welcome to Bamboo Inda. This is not decorative grass. It is high-performance bioengineering. Bamboo possesses a tensile strength that rivals mild steel, capable of withstanding 28,000 pounds per square inch. In a seismically active zone like Indonesia, rigidity is a death sentence. Concrete cracks under sheer force. Bamboo flexes. The fibers stretch and compress, absorbing the kinetic energy that would pulverize a brick wall. A massive column bends under the load, dampening the vibration before snapping back to center. Elasticity is survival. The architecture replaces air conditioning with aerodynamics. The curved, open structures of the moon house utilize the thermodynamics of the wind to cool the interior. Even the ground beneath your feet serves a function. Floors of tempered glass suspend directly over freshwater ponds. Koi fish swim inches below the living space. This is not just a visual trick. The water mass stabilizes the ambient temperature. Outside, the pools use volcanic stone and vegetation for filtration instead of industrial bleach. The entire complex operates with a zero chemical footprint. In the tropics, architecture breathes, but 250 kilometers north of the Arctic Circle, it must seal. Hotel Kakslautanen in Finnish Lapland faces a brutal reality. Outside, the mercury drops to negative 30 degrees Celsius. Inside, the climate control holds a steady positive 20, a 50-degree temperature differential. Separating these two worlds is a few centimeters of engineered transparency. The structure relies on thermal glass with embedded heating elements. This is not passive insulation. It is an active shield. The system warms the glass surface just enough to prevent the moisture in the air from turning into ice. Condensation is impossible. The snow melts on contact. The result is a sensory paradox. The eyes see a lethal frozen landscape, but the skin feels the warmth of a living room. The guest lies back and looks straight through the heated ceiling into the polar night. We leave the fragile transparency of heated glass for a monolith of absolute density. In the rough waters of the Solent Strait, a dark circle breaks the horizon. This is no man's fort. Commissioned in the 19th century, this artificial island was born from paranoia. The British Empire feared a French naval invasion. The response was brutal engineering. 4.5 meters of solid granite, walls thick enough to stop heavy cannon fire and support the weight of 49 guns. The enemy fleet never arrived. The artillery fell silent, but the stone remained. Today, a multi-million-dollar renovation has converted the barracks into a luxury retreat, yet the military skeleton dictates the experience. Outside, a winter storm churns the sea into a frenzy. White water slams against the fortress base with the force of a battering ram. The roar is deafening. Inside the dining room, just meters away, the air is still. You see the violence through the gun ports, but you do not hear it. The granite absorbs the chaos. 22 suites hang suspended in the void between the coastlines. When the last boat leaves, the isolation is total, just the stone-cold quiet. From the artificial granite of the sea fort, we shift to a structure carved directly into the planet's crust. But how does a habitat buried inside solid rock avoid becoming a cold, damp cellar? In the high desert of Farmington, New Mexico, the architecture creates its own environment. This is Cocopelli's cave. The structure is driven 21 meters deep into a vertical cliff face. That is the equivalent of a 6-story building completely submerged in stone. The surrounding geology is Ojo Alamo sandstone, a sedimentary formation that solves the primary challenge of desert living:
Extreme temperature fluctuation. The massive density of the cliff creates high thermal inertia. The rock absorbs solar radiation during the day and releases it slowly through the freezing night. It is a natural battery for heat. While the external air swings violently between extremes, the interior remains locked in a static range of 18 to 22 degrees Celsius. No air conditioning.
No heating grid, just physics.
Originally drilled as a geologist's research bunker, the space has been expanded into a 150 square meter residence. The walls are not decorative plaster. They are the raw, textured timeline of the Earth itself. Modern climate control is rendered obsolete by a geological shield that has existed for 65 million years. Exiting the stable thermal mass of the underground requires a radical shift in elevation. From the depths of the Earth, the focus ascends to a precipice hanging 150 meters above the Indian Ocean. Here, a retired Boeing 737 fuselage defies gravity. It did not land on this remote Balinese cliff, it was dragged here. Transporting 30 tons of aviation aluminum through narrow jungle roads was a logistical nightmare. The solution was surgical destruction. Teams severed the fuselage into distinct sections for transport. On the ridge, cranes maneuvered the massive segments into place. Welders reconnected the skin inches from the drop-off. A jigsaw puzzle of industrial metal. The visual contrast is absolute. Polished aerospace alloys against jagged wild rock. To prevent the airframe from sliding into the abyss under high wind loads, the landing gear is bypassed. The structure locks onto a custom reinforced concrete foundation, driving steel roots deep into the cliff face. While the cockpit now houses a stone bathtub, the sensory reality hits on the wing. Standing on this cantilevered terrace, the roar of updrafts battering the aluminum skin is deafening. You are walking on a flight surface that is stationary, yet suspended over a lethal drop. But even this cliffside luxury pales when the engineering objective shifts from comfort to absolute survival in the death zone. From the retrofitted fuselage of a private jet, we shift to a fuselage engineered specifically for the mountains, 2,835 meters above sea level, the Mont Blanc Massif. Here, the Bivacco Gervasuti is not a hotel, it is a survival station grafted onto the Repurposed glacier. The structure looks less like architecture and more like a space capsule that crash-landed in an alien landscape of ice and granite. The shell is a masterpiece of composite engineering. It is not built from brick or timber, but from a sandwich of fiberglass and high-density foam, materials pulled directly from the aerospace industry. Outside, winds scream at 100 kilometers per hour, blasting ice crystals against the hull. Inside, absolute silence. A few millimeters of composite material separate a warm, 12-bunk microclimate from a lethal freeze. The tube hangs cantilevered over the precipice, with half the structure floating in empty space. This is not an aesthetic choice. It is physics. The aerodynamic shape and precarious position allow snow loads to slide off instantly, preventing the weight from crushing the cabin like an eggshell. Solar panels feed the life support systems and weather computers. Staying here costs a trivial donation of roughly 10 euros. But money is not the real currency. The true price of admission is a 4-hour vertical ascent through cracked glaciers, where one slip means falling into the void. If Bivacco resists nature with composites, the next structure is created from the thread itself. From snow. Igloodorf relies on the engineering of the arch. Blocks of compressed snow support tons of weight without a single steel beam. Gravity locks the ceiling together, but the real protection is microscopic. Snow is a powerful thermal insulator because of air bubbles trapped between the ice crystals. These millions of pockets arrest heat transfer. They create a dead zone where the cold cannot penetrate. Outside, the temperature plummets to minus 20 degrees Celsius. Inside, it holds steady at 0, a 20-degree difference, created by frozen water. This thermal shield functions strictly until the equinox. In spring, the physics surrender to the sun and the entire hotel dissolves back into the earth. From the dark ice cave, we transport to an object of absolute transparency. This is not a cabin. It is a 55 square meter industrial unit dropped into the Norwegian wilderness. The primary structure is a rigid exoskeleton of galvanized steel. An X-ray view reveals a frame engineered to withstand vertical pressure equivalent to several meters of wet snow. Zero deformation. The walls are non-existent. Floor-to-ceiling glass dissolves the barrier between the occupant and the freezing forest. Touch the exterior surface and you feel the biting cold of polished plate glass. Inside, the environment is sterile and monochrome. Zoom in on a light switch. It clicks with the mechanical precision of a cockpit control. No wood, no rustic decor, just cold metal holding back the winter. The shelter acts as a high-tech vitrine for the wilderness. For 1,000 euros a night, the luxury is not the service, but the profound silence. We leave the open Norwegian forests for the subterranean density of the Indonesian jungle. The first sensation here is auditory subtraction. Above ground, the Ubud rainforest generates a constant 80 decibel wall of insect static. Below the surface, the earth absorbs everything. This is the Cave Valley. It is not a romantic hideaway. It is an exercise in geothermal engineering. The structure cuts directly into the bedrock, using the immense mass of the surrounding soil as a thermal battery. While the surface temperature spikes, the rock maintains a constant cool baseline. But in a humid equatorial climate, how does a buried chamber avoid becoming a suffocating trap? The answer lies in fluid dynamics. The design enforces precise cross-ventilation. Air currents are channeled through the descending stone corridor, stripping away moisture and preventing stagnation. It creates a breathable, dry microclimate without heavy mechanical aid. The rock walls provide more than just thermal lag. They create near-perfect acoustic isolation. No vibration, no external frequencies. Access to this geological silence requires 250 euros per night. We have traveled from the glacial peaks of Mont Blanc to the volcanic depths of Bali. This trajectory maps the evolution of shelter, from defying gravity with aerospace steel to mastering thermodynamics in the underground. To fully visualize these isolated frontiers, we utilized advanced artificial intelligence simulations alongside archival records. Digital reconstruction brings the remote into focus. The boundaries of human habitation are no longer defined by geography, but by engineering. Now the choice shifts to you. Suspended in the air or buried beneath the earth, which of these environments would you trust with your life?